Welcome to Oracle ADF TV. My name is Frank Nimphius and I'm from the Oracle JDeveloper and ADF Product Management team. In this session we talk about performance optimization on the controller and on the view layer. Now let's start with the controller layer. On the controller, well, the most important setting is to use a shared data control whenever you can. If the use case requires an isolated data control, then there's nothing wrong with using that. However, most of your task flows should be in shared data control, and the reason here is that because the shared data control will reuse an existing instance of a data control within the task flow. Especially when you use ADF business components, having an isolated data control means, so that you kind of isolate your transaction, you will have a separate application module launched as a root application module, which then actually creates another database connection. And now you can imagine 500 users on a system, and just overdoing it with the isolated task flows will result in an enormous amount of database connection, which will have a performance impact. So, rule of thumb, by default, always use a shared data control. Otherwise, if the use case requires it, just have the isolated data control. Region is a very popular functionality within task flows, as it allows you to run specific tasks within a page without leaving the page. Now, there's some kind of magical number, and I don't know where that number comes from, which says that 10 is the maximum amount of regions that you should have on a single page just for good performance, so you shouldn't cross that. As said, it's a magical number that I don't know where it comes from and if it ever was measured, or just if this is a developer experience. Anyway, so you can imagine that if you have a lot of regions on a single page, then there are a lot of task flows to load, and with each of the task flows there are queries associated, and given that task flows in a region don't load in parallel, they load in sequence, definitely that has an impact to the performance. So what can you do? Well, what you can do is to be very realistic on the number of regions that you need. Maybe sometimes just navigating off to a different view to show a different region makes sense. However, if you need to have all of the regions in one page because you want to create some sort of desktop experience here, then the recommendation would be to use tabs, and then on the hidden tabs make sure that the task flow that is exposed in the region, that this task flow binding has a setting to deferred loading, so that the loading of the region will happen as soon as you switch to that tab, so when the region becomes visible. Also, what you can do is you can make sure that you can switch off regions, so to say. So once you're done with a specific task, you may want to decide to switch to an empty region, which is a technique that you can do with dynamic regions. So if the dynamic region first loads a task flow and then you switch it to an empty string, then basically that will represent an empty region, and that doesn't cost you as much of a memory or resource consumption than a real working region would do. However, requires you to do some investigation into that. So first of all, investigating into empty regions, but then also investigating in finding the hook points to when you want to refresh the region. Typically you will have a selection listener on the select item within a tab, so that when you click on a tab, it will make sure that the region is refreshed and then shows the task flow that you want to see and that you want to work with. Also keep in mind that if you switch from a task flow to an empty task flow, then all of the task flow state will just be dismissed, because the task flow will just go out of scope and will be garbage collected and is going away. So that might not be the solution for all of the use cases. However, for you to know, be very, very careful with the number of regions that you show on a single page, and if you can, decide for deferred loading using, for instance, tabs. High availability, well, some of the applications are very important to you and your business, so for that reason you want to make sure that no requests remain unanswered. Now, even if there's a problem with the service, you want to make sure that the user will be satisfied with a subsequent request, and for this you can set up a failover, which means that in a clustered environment the request of a user will be routed to a next server, and then the user will not experience any disruption in the work. However, this comes with a little bit of overhead in terms of a serialization and deserialization of the states that the controller holds. So if you don't have any plans to use failover, recommendation for better performance is to switch that option off, or actually don't switch it on. On the view side, well, these are mostly settings that you do in a web.xml file that change the overall framework behavior. Of course, and we stress this in our best practices and programming best practices for all of the kind of layers that we introduce in ADF, there are programming practices that will allow you to increase or actually ensure good performance. And if, for instance, you have a lot of iteration happening, or if you have a lot of JavaScript executing on the client side, that all might just go into additional load and additional load time and performance problems that you might experience here. So we can't look into that, but the framework has some facility and some configuration settings that actually allow you to tweak the performance of the framework. Now, one thing that is quite handy when you work with ADF and ADF Faces is that you can switch off a lot of debugging stuff. You can switch off the compression of the style sheet, you can switch off the compression of the JavaScript, you can switch off the compression or actually the caching of the page, so that if you run a new version of the page after doing some changes, you make sure that you're not served from the cache, but actually that the file is read in again, so that you get the latest and greatest of the state of the file. Now you can imagine that all of what I mentioned will just add to negative performance, because the file sizes are bigger. If you're not read from caches, then that means basically you have to read the page in its full content from the server all the time, so that partial changes on the page just wouldn't have no effect, so to say. So make sure when you move your application from development, from testing into production, that all of these settings like file modification that you see here or content compression is actually set to a production quality, which means that you go with style sheet and JavaScript compression, and you go with check file modification to false, so that actually will take the file that goes the first time served, because in production it's not expected that you change the page. The other option is to talk a bit here about state caching. So there is a client token that the framework keeps track of, and the default setting is 16, so that means that beyond of the current view that you're looking at, there are tokens for 15 previously visited views, which basically would allow you to just go back using the browse button. But as you know, the browse button typically provides you other problems, as the state not necessarily is the same and synchronized between the server and the browser if you do so. However, you can use the browse button, at least the page actually will be rendered properly and in a fast manner. However, if you experience problems with the performance, you may want to try and reduce the number of cached state tokens, because a state token capped on the server will take memory there. So if memory is your problem, you want to reduce the number of kept state tokens. Root caching, well, this is if you have a desktop live experience. ADF Faces has the ability to cache the view root of the whole page that you're looking at. Now, if that is a very sophisticated page with a lot of regions and just a rich desktop experience with a lot of Ajax thing happening, maybe you're using a dynamic tab shell, or if you're in Oracle Fusion apps, you use the UI shell, then this is something that you want to try and test, because what it will do is it will just capture a snapshot of the component tree, and then will dismiss that component tree as soon as you navigate to another view ID. But for as long as you stay there, this cached version of your tree will be there, and that will allow you to have much better performance. Of course, the memory footprint is a little bit higher than normal, but actually it's not that it will be that bad. But it will give you, for desktop experience application or desktop forward-looking applications, it will give you a much better performance. So you want to try that out. Another thing to try is to set the compress view state. Now, what will happen is that by default we keep track of a specific view as you work within the application. As I mentioned, there are 16 snapshots that we typically look at. Now, this is by default saved in a non-compressed way, which means that we take memory. Now, if memory is a problem, then what you can do is you can compress the view state on the server side. Now, whenever there's a request for one of the previously used views, and if there's a token still available, it needs first to be decompressed and just put to its full extent. However, what you will win by this is you will win a 30% memory for the cost of 4.5% of increase in CPU. And remember, the triangle I showed on the first session where I said that there is a triangular dependency between network, memory, and the CPU. And if you go for good performance, typically you try to shift bad performance that you experience of one of these variables, like memory, to one of the other. So this is something that you can try. Then resource caching. Now there is something called the resource servlet in ADF, and it's automatically set up for you. And basically all of the resources that are in a directory with /resources actually will be routed to this resource servlet instead of just going through the Java Server Faces servlet and being downloaded that way, in which case it wouldn't be cached and it would go through the full Java Server Faces lifecycle. So this is what we do automatically, and then you can configure the web caching behavior on the JDeveloper and web.xml setting as well. Just have a read in the web developer guide for what the options are. So that said, if you have your own boilerplate images or JavaScript, you can configure your JavaScript the way that actually it will be run through the web cache and run through the resource servlet for that reason. Typically what you do is you will put your images into a zip file, and this zip file will have a manifest, and this manifest file and the structure of this file actually will contain resource as the first, or resources as we see it on the slide, as the first directory. In this way the resource servlet will recognize that it will have to deal with that call, and then you put the jar file into the web.inf directory and then configure it so that it loads with the application. There's a document on ADF Code Corner that explains how to create a jar file as a zip compressed file and put it into your application so that all of the boilerplate images are served from that jar file, and this jar file also follows this notation so that the resource servlet will take it over. That makes sense for having a lot of icons and images on the application. Probably doesn't give you bigger benefit if you don't have a lot of images in there, but you want to give it a try and see if that could improve performance. And another benefit here is, of course, that if you use a jar file, you have a central piece of file where all of the images go, so that if you need to share it between applications, it's just a matter of moving the jar files to the other applications as well, or just make it a shared library. A few things to consider when you build applications. First of all, be very careful with component IDs. I know that if a component ID is kind of descriptive, then it's easier to read. So if I have a text field with a first name and I call it first name 1, then of course that speaks even from the component ID level if I look at the source code. But component IDs are not compressed, and that means that every character that you put as an ID will go as a byte. So you're kind of artificially increasing the page load and therefore the load that needs to be brought to the client. So we do have an audit rule in JDeveloper that flags all of the component IDs that are longer than 7 characters. However, make sure that even if you go beyond that, you're sensitive, that you don't overdo it. If there is a need, for instance, to use JavaScript to access a component, for that reason you have a descriptive component ID, make sure that only that component then is descriptive and the rest will just go with T1 or what the default setting is, just for better performance. The client component flag is something that you find on all of the ADF Faces components. Now what the client component flag is doing, it actually allows you to use JavaScript on the client side to access that component. Now you can imagine that there is no need for all of the components to have the client component rendered, in which case an additional JavaScript object will be rendered on the browser. So avoid using the client components being set to true. There is one use case actually where you want to do this, and that is when you work with JavaScript. If you want to work with JavaScript against a client component, and only if this client component doesn't have an AF client listener assigned to it, then you set the client component to true. For all of the rest, all of the partial triggering and the partial refresh behavior, now everything will be handled without. So you don't have to set it, and this is why the default setting is client component equals false for all of the components, in which case we generate HTML for the component on the server side and send it to the client, which is more efficient. Then quite often you have the requirement to conditionally show or hide areas of a page, and here the recommendation is, instead of just use the display property to hide it, just use the render property to not even render it. You can imagine that if you set the display to hidden, then these are hidden fields, and with all the content that the field has, it would just go through the life cycle and then will be downloaded in its full length, just being hidden. So you can avoid this extra load, especially if chances are that users don't switch to make it visible just by using the rendered property. Now, if you use the rendered property, what it means is, however, that the component itself cannot be partially refreshed. So to switch it back to visible, you will have to partially refresh the container. So that's a surrounding parent. But that's all that you need to do there. For PPR, or partial page rendering, that's a preferred mechanism. So you should set, where you can, fields to auto-submit, the buttons to partial submit, and then use the partial trigger property on the individual components to refresh a component to show different data in response to the action that happens. This way you avoid that the full page is re-rendered. And if the page then, in addition, is based on the template, then it's even getting faster because you have the chance that you can use even more already client-side cached boilerplate images and content. So use partial page refresh. Make sure that everything that you build within ADF Faces is kind of thinking in Ajax. So just partial submits, partial refreshes. And in 12c, if you're on 12c, there's a new component that we implemented, which is called AF Target, that allows you to be even more sophisticated and more fine-grained in the control of which areas within the page will refresh in response to a specific action happening. There's on the ADF Insider webpage, and you just Google for ADF Insider, there is a recording I did about the life cycle, and that life cycle recording, it's actually called Avoiding Lifecycle Frustrations, but that contains a lot of information about partial submit, auto submit, and how it all works, so that you have a good understanding how to design your pages for maximum efficiency. There is I wouldn't say hidden feature, but there is a feature not very commonly known, and that is a way that you can use partial navigation. Now, for partial navigation, and you find the description for this in the appendix of the web developer guide. So it's not in its own chapter, it's in the appendix under the configuration options for web.xml, for the web.xml file. And partial page navigation, what it does is, it doesn't change the page. So basically you start with a home page, and then that page is used as a container. Now we implicitly create an iframe around all of the other pages contained in that page. And then when you navigate from one page to the next, you do the partial navigation, which means that we only flash out and change the content that needs to be changed. And this is almost fast like lightning. Yeah? So compared to a traditional page-to-page navigation, that's a huge improvement. There are 3 known issues or limitations with that, all documented in the appendix. You want to have a read through this. One, for instance, is the reliance on JavaScript objects, because if we don't refresh the container, then JavaScript loading with the initial page will not be refreshed or renewed. So if you have a dependency on this kind of functionality, then partial navigation wouldn't work for you. So you want to read on what the limitations are, have a good understanding what the impact would be to your application. If there's no impact, just set it to use partial navigation, and we will experience a great improvement in the navigation between pages. Well, that was the 3rd recording, so 3 recordings all about performance, optimization and expectation. We started with measuring performance recommendations for this to get your testing right. We then went to ADF Business Components, just talked a bit about application module pooling, about passivation and so on. And now we concluded with task close and with a view. However, still, if you optimize everything, you'll never be happy, because you always think that there will be something that you can improve in performance. So this goes back to the first recording where I said, avoid premature optimization because it doesn't make you happy. Spend the time on areas where you know you can improve your application. And for this, you need to understand where in your application things are currently not optimal. And then also what is the goal that you want to achieve in terms of performance. Once you're clear on that, I guarantee that you write better applications. Have a look out for good developer guidance, so write your own developer guide whenever you learn about a good technique that will reduce the number of fetches. We talked about opt-ins in the ADF Business Components section, so you want to have this written into developer guide so that the developers are aware that if they query database information and you halfway populate an entity, so not populating all of the attributes, that if there is a dependency to a non-queried attribute, that actually they're adding an expense. So that's the recommendation, and that concludes all of the performance talk that we have. As mentioned, there are 2 books, the Fusion Developer Guide, detailing everything about application, module pooling and view object optimization. And there is a Fusion Middleware Performance Guide that has a full chapter dedicated to Oracle ADF, where we talk about ADF Faces settings and as well about the task flow settings.